Hi, welcome to Knowledge Representation for Automated Process Planning with Darwin Peterson. Quick reminder, keep that chat open, and we may have some polling too. All right, now it's my pleasure to welcome Darwin Peterson, Tools, Processes, and Governance Manufacturing Engineer at Spirit Aerosystems. Take it away, Darwin.
Oh, good morning, everyone. It's nice to be back to another IKAA conference. And for those of you who attended last year, this presentation is an update and additional information on the same topic as I presented last year. So just a couple of slides and comments about Spirit Aerosystems. These photos here and the next slide are not relevant to this particular project. Specific things that we're working on. These are stock slides. The top one is the automated fiber placement on the 787 fuselage, and the lower one is subassembly in Subang, Malaysia. Spirit is a global company with activities all over the place. We're trying to get a balanced spread between fuselage, propulsion, and wing, and working on increasing our presence in defense activities. So we have a lot of interest in a lot of different places, and are actively pursuing engagement in all of those. We have plants in Kansas, Oklahoma, North Carolina, Texas, Malaysia, multiple UK sites, France, and Morocco, and a few other places as well that I probably missed with some recent acquisitions. From this slide, this is probably needs some update. It's been a tough couple of years. In the last couple of years, we were right at our highest production rate ever for Boeing on the 737 MAX when the grounding of the MAX happened, and then COVID and transportation shut down. So it's been a challenging couple years, but we're working through the recovery. So this particular project, to give you some context here, and those of you who saw last year, hopefully this will give you a little better understanding and more background. The context for this knowledge management and data preparation task was to support a generative process planning application or applications as needed from CAD assemblies. And the output had to support human and machine interface and instruction. And there were many outputs in different formats. Manufacturing data sets. The manufacturing plan is a JSON file. We also output kit box information and other similar kinds of things. These are floor beams. So it's a floor beam assembly line. There are 3 automated stations, fully automated, 3 are semi-automated, and the 2 others are manual with multiple tools to assist the mechanics. This content represents 40 plus aircraft stations, which is a numerical location fore and aft in the aircraft, which represent over 300 discrete configurations. These were previously what we would call configurable materials. So for each line unit, the configuration could be different, but we revised them when we did this project, and these are now part number controlled. Floor beams are the most variable part in the aircraft, or one of the most variable, and so there's a lot of configuration changes to support customer options. That meant that our tools and processes that we developed, we knew were going to be used a lot ongoing. So it couldn't just be a project and a team focused on getting this work content reprocessed to support the line. It needed to be maintainable for new content as it came over time. Aircraft typically has relatively low rates and high variability in terms of parts and processes, and overall, as a general rule, that makes it difficult, excuse me, to justify unique automation. In this case, it's a hybrid situation. This is kind of a sampling, a high level of basic part types in these assemblies. Some are with or without electrical bonding requirements, some installed with or without sealant, some both, some post-assembly sealing, and there's also some bonded components, adhesive bonded components. So there's a variety then of standard parts and engineered parts, which we just grouped under one contextual grouping as brackets, even though in reality they're not, but from a contextual usage standpoint was sufficient. So how did we approach this problem set? Some of this engineering is relatively new, and other content's been around for quite some time. So in addition to variation that would be normal that you might expect from engineering content and format, it's significantly different because of different time frames in which content was created. So we needed to build a whole series of tools to get that content into common and desired CAD content and format. We also quickly recognized that PLM or ERP databases were not really conducive to supporting the kind of content that we were going to be creating. That we needed the ability to rapidly create new objects and relationships. And there's an exponential increase in those new formalized objects and relationships taking this approach. Standardizing the engineering then with the flexible database structure, which we're doing in Neo4j's graph database, becomes the foundation on which we then support our generative process planning applications. And AROS is our knowledge backend for the applications. So a little discussion about this first. Had some interesting conversations about this with many people over the years. And I think there's a tremendous amount of misunderstanding in some circles. So I included this slide just to try to clarify and level set. Probably most of all this audience, everybody understands, but the kind of knowledge we're primarily talking about is what this is to discuss. So this could be a long conversation and presentation all its own. There's been a lot of interest in artificial intelligence in recent years, and primarily the computational and natural language understanding. Explicit or heuristic knowledge was very popular in the early 90s, and sadly, from my experience and perspective, kind of fell out of vogue. I believe there's a broad false perception that it has been replaced by the computational or natural language. From my personal experience, having been in this space my entire career, over 30 years, the value of explicit knowledge is almost impossible to overstate. Sometimes it seems so inherent, so simplistic, it's easily overlooked or undervalued. It is, in many cases, I believe, is part of the foundation that's necessary to support the other two types. The foundation of the AROS toolset is really explicit knowledge and provides tools to facilitate the growth of this knowledge as well as its effective use. In this project, we're dealing exclusively with explicit knowledge. However, we at Spirit, myself and others, have been involved in a number of other projects over the years dealing with both of them, but that's a different conversation. So anyway, as a level set, that's what the kind of knowledge we're talking about. So how did we proceed then with that background of the kind of knowledge we're talking about, the product structure and the intended build process? we began to engage in the specific task of trying to explicitly represent this knowledge to support a process planning application or applications, as the case may be. Knowledge, by definition, all of you who have been involved in this space understand this, but it's highly contextual. You will notice that in several other prior presentations yesterday, comments referring to this. I would say it is one of the ongoing challenges, and people that desire to develop skills um, in the knowledge acquisition and representation phase need to be fully aware of this and develop their skills in it, because context can radically change things. So the more complex and involved the context, the more challenging the representation in at least many cases. So this particular project is, of course, manufacturing processes, but in principle, I would say it's the same for any other. Okay, so a little more specifically, what did we do then? How did we proceed? We started doing to follow along with a heuristic idea, um, and a heuristic about heuristic knowledge. Even is if you expect that your initial attempt is going to be 100% accurate and complete, you're probably naive. Um, so don't stress about it. Don't worry about it. You do the best you can and you work with it, and experience will refine it. So over the years, I've had this experience with many people, and people that you try to work with, and sometimes they get extremely stressed about trying to offer what may be their expertise, and all of a sudden they're insecure about it when they think you're going to formalize it. Um, don't worry about it. Experience will assist you in refining it. So we began to create, you know, obvious initial KPAC for station rules that were, you know, things that were more explicitly stated in the process of this development of this whole line. But also, those of you who've been involved in this very long realize that most rules stated by humans for humans are often not very usable. They have to be put in much more controlled and explicit form, structure, and terminology, and that's where the global parameters begin to explode and have to be created to represent things. So we began to create these, but to illustrate the point, over time, as your learning increases, this in a set becomes in a set, and content becomes much more extensive. A point about sets there is the rules engine and sets are extremely powerful and useful in that context. So, for example, if you're not changing input or output parameters, from an application perspective, it isn't no any different. Doesn't matter. The flexibility of the logic with inside can change, be restructured, added to whatever you need. The end result becomes the same. So that's very helpful. Then, of course, the inevitable happens as you continue to learn more. One becomes many, and the growing content became a bit confusing and frankly overwhelming, even for me, and I was the one putting it all together. And for a programmer and others trying to be involved, they were really lost. So I quickly recognized the need for much higher level organization and more knowledge of context. Right, so context for the knowledge, but knowledge about context itself at an even higher level becomes another important idea. And I see a question pop up, so let me address that one now from Thomas. What's the reason to use a graph database with ROS? How do ROS and Neo4j interact? Excellent question. So A graph database is where we manage and control this new set of relationships and content of engineering structure to process content and structure. So it becomes where everything ends up. Okay. So the application reads content from there. It accesses ROS, and outputs as the process continues also end up there. So it houses manufacturing data, process data. It houses our output content, and it houses the restructured engineering content that we've created. Did that answer your question? Any others relative to that? Anybody before we move on? Okay. So then to deal with that, I made another step forward, which was I began to create a higher level knowledge map. And you can see I did this in PowerPoint, and there was some conversation I had last year, and that I had hoped to spend more time working on method K-Packs to represent this, and eventually that's where we intend for this to be. But after some attempt and activity there, I realized that the extent of what we wanted to accomplish, we could not do at the current functionality and with APIs. So based on my workload, I put a pause on that for the moment, but we will get back to it eventually. So what I did is basically mapped the vertical swim lanes represent, at least conceptually, it's not 100% precise, but the kind of content that needed to be developed as this process executed. And so the blue bars represent an identified set ID, what its basic content was for, and the extent of the results that were coming out of it for the application. The other thing we quickly recognized from a context perspective was the need to give guidance more to the application, and not just the programmer, but to the application itself, to try to reduce as many things as possible that were ended up in hard code. So we began to put output in the sets of what set to go to next based on what's happening contextually. So the little red arrows represent that content, where things are going next in the process, and you can see that it comes together later in terms of content. So the application has to collect a lot of information, pause, process through components in the BOM until it has sufficient information to proceed with then organizing that content that's been provided. Here's an example of a different context and how knowledge can be different based on the context. So in our business, fasteners is a huge part of things, and engineering does not typically call out a complete explicit fastener. You typically just get a base number, maybe a diameter or diameter code. You have to have one or the other, but depends on the program or the OEM, what content structure is like. And these automated manufacturing stations, part of the learning process along the way is differences within them and differences in some of the standard parts necessitated that we take a different approach to calculating fastener length, which turns into a fastener code, which is part of reassembling an actual fastener number, which is necessary to determine if you can do the component in the station. And so what we ended up doing is, even though fastener in general was the same approach, calculate the length to come up with the appropriate length code. And so that's is a simple and effective way to manage context changes, where the larger context may be, very similar minor change with the KPAC, you can come up with an appropriate contextual difference. Last year, I had a little more content on this, or removed some of it, but a little further explanation. Process planning, by definition, is really a series of process assignments. So there's lots of grouping, sequencing. Processes can have processes, and rules can exist at each of those points in the process. So you need ways to effectively associate content at many levels and be able to communicate that effectively. So the approach we took, and statement here, value tables weren't really designed for this. It's a bit difficult to manage if it gets too big, and if it gets really big, it would be a bit unfeasible. But at this point, it works for us. We made named parameter names to indicate sequence of a step or process. We made a parameter that relates to it based on its name for lower level content. So if a step has rules about content that needs to be provided at a step level, that's there. We also have content that exists at the definition of these, and these are their own KPACs with a particular explicit structure within them that also provides contextual rules about its usage inside this larger context. So we've utilized the KPAC in those, and I had a slide that expounded on those a little more last year. I removed it this time, but we used about every mechanism possible in the KPAC on these from a work instruction and process perspective. Jeff asked, do we use global parameters? We use global parameters exclusively at this point. Okay, other projects. There are a number of very similar projects at various stages of development pursuing this very same task. Interesting challenges, of course, with all of them. There are differences in each one because of just different approaches to the build, different product structures, and all of the challenges that manufacturing normally provides. But the foundation of this project is what we're using for all the rest of them. Don't recreate what we don't need to recreate. So same approach for data creation and structuring, or knowledge management, plan authoring, etc. We're taking the same approach for all of them. One simple example of a difference in these is, and this came from a slide last year, the idea of the process in a process. One of these that we're looking at is definitely going to have at least one level deeper of this process and a process and a process situation, which is haven't figured that out yet how we're going to do that, but another interesting thing to work on and deal with. And our initial project has begun to generate a tremendous amount of attention and interest in the value of knowledge management. So we're generating lots of ideas for further activities that are also in work. Providing work instruction process parameters in real time is one conceptual area of activity. Things like torque, heat treat, temper verification, and others. Some of these, and all of you are involved in understanding and using process specifications. You know, some of those are not terribly easy to use, and typically specifications reference many other specifications, and it can be an extremely long trail of finding and interpreting content. So we're looking at how to improve that for users in the factory and to make it something maintainable from a manufacturing engineering perspective, because, as we all know, specifications can change. Regulatory agencies and OEMs are increasingly asking more explicit information, content in work instructions, and more content and data capture for objective evidence. So we have a lot of activity involved in those domains as well. We are in the, well, let me address this first. Some things to consider if you're interested in these, what's the boundaries in your business between training and work instruction? What are your relevant regulatory requirements? How complex or extensive are the variables and parameters? How risky or expensive? How much effort is involved in looking them up? And what's the cost of failure, which of course nobody wants. We're also in the early stages of mentoring and developing some subject matter experts in the knowledge aware approach. We believe that knowledge aware coupled with automation enables right-sized technical workforce, that it really facilitates continuing to broaden and deepen people's product and process knowledge, which is just extremely valuable and should result in employee satisfaction, increased productivity, and retention. I visited with someone involved in another manufacturing industry recently, and they showed me their really difficult situation in employee retention that has to get fixed if they're going to survive. So this certainly should help. And the obvious results of improved quality and reduced costs when you know what to do and you know how to do it. And personally, people matter most from my perspective and experience. Promoting the development and use of people's intellectual capital makes them interested and excited to come to work, and particularly when they can see their efforts become incorporated. Question from Bill: do you have the actual contents of your work instructions typed out in KPACs, or are they still in Word documents? Great question. So yeah, that was in my presentation last year. I took that slide out. I probably should have left it in. They are in a KPAC, and we've utilized them such that we can have a simple version and an extended version as needed. And so they are viewed as a standard work, and things that are not standard are produced as variables and displayed as relevant graphics from the CAD for that particular process. So hopefully that answered your question. Further development suggestions. This slide is pretty much the same as last year. I added the two rows at the bottom. APIs for method KPACs. We do think these are a logical solution for standard patterns for sequenced sets of activities, and a really good logical way for rules in context of sequence and activities, and for logical looping in hierarchies, and as a way to demonstrate that logical map. Array processing value tables are designed for a single set of inputs. Find a row will give you an output. So a set of inputs gives you a set of outputs. But in this context, there are really cases where, as a simple example, you have an Excel file, you have a stored sort set of rules on top of it. And regardless of whether it's one row or thousands of rows, you execute that sequence on it. So we think there is some opportunity for that kind of processing as a context. We think regex in the toolkit would support some enhanced logical expressions. And in context of some things I showed earlier, output or a graphical output that would visually show KPAC relationships in sets, I think would be helpful, kind of like I had in my PowerPoint screenshots. And in many of the presentations people have using, pictures, graphics inside KPACs. I think a simpler method to incorporate graphics would be very useful as well.
Well, thank you, Darwin, for all that information. I'll give you a moment to wrap it up.
Okay.
And we're
We're,
running low on time, but great
all right.
stuff.
We're just about there. Okay.
Yes.
Collaboration interests. Anybody interested in these things, you're welcome to contact me directly and communicate with us. We're interested in those. And a quick at the end here. I am the primary author, though there's multiple users. That will change in the fairly near future. We have over 530 K-packs, over 190 sets, and 5 communities of practice.
Awesome. And yep, Jeff is saying great enhancement requests. I completely agree. Appreciate, Darwin, you taking the questions as we went through. So we don't have any outstanding questions. And I want to let you know I pasted the survey. It's just 2 seconds. I think it's literally 2 questions. Click on that link. And you can always reach out to Darwin, right? If they have any
Yes.
additional questions. Perfect. Okay. Well, that was great. And next, we'll be heading to a session with Dan Cronin on ABS digital rules at 10:20 Eastern in just about 4 minutes. So we'll see you over there. Thanks so much.